Good afternoon. My name is Garrett Whitley, and this is my Module 6, Assignment 1, determining the level of statistical significance using the ANOVA for repeated measures. So for this assignment, we will say that the null hypothesis is that there is no statistical significance between chocolate given to the and based on attitude of the observed test subjects. So for this, we'll go to Analyze, General Linear Models, Repeated Measures. For this, our within subject factor name will be factor 1, and we'll use 4, number of levels, we'll use 4. We'll click Add. Define. Our attitude 0 will be the number 1 here for our variable. Attitude number 1 will be our variable number 2. Attitude number 2 will be our variable number 3, and attitude 3 will be variable number 4. For our post hoc test, we'll use the EM means tab. Click factor 1. Factor 1 will be displayed means for, compare means, main effects, and then our confidence interval adjustment will be the Bonferroni. And we'll click continue. And options, we will display our statistics for descriptive statistics and continue for that, and we'll click OK to run our output file. Now for this, we'll look at Machli's test for sphericity, and we see that the level of significance is 0.683, which is greater than 0.05. Therefore, the assumption is met and the null hypothesis is rejected because there is a statistical significance between the attitude and the chocolate given to the test subjects. So we can continue on and look at the pairwise comparisons to see where the level of statistical significance is. For this, the numbers that are less than 0.05 show that there is statistical significance, so 1 and 2. 2 and 4, and those are the ones that have statistical significance because those are the ones that are less than 0.05. So for the next piece here, we'll use the F value here. Our F value is 32,645.93. And we can see that the level of significance there is obviously less than 0.05. Therefore, again, our null hypothesis is rejected because there is a statistical significance between our two factors. But for this, we'll look at the degrees of freedom, which is 1, and the error is 22. So we will go to our F distribution table with our F values for alpha at 0.05. We'll look here at degrees of freedom for our numerator, which is number 1, our denominator, which is 22, and we see that 4.30 is our critical F value, and 32,645.93 is greater than 4.30. Therefore, there is statistical significance based on that.